So it says that you have two people running, right? Maria is running at 9 meters per second, but is behind Juan by 40 meters. Juan is starting from rest on his motorbike that accelerates at 0.9 meters. So I started off with the motion diagram last time. I think this time I'm going to plot it first because I did poorly on the plots and I missed some of the plots last time, and I don't want to do that again. So let's go look at this thing here. So what I want to look at here is that I want to go do this. When I picture Maria and Juan, Maria is running, but she's 40 meters behind. So let's draw a plot of this thing. So so my first step here, right? Step one, when I'm saying draw motion diagrams, I want to conceptualize the motion. And so what that really means here, right? It really means two things. Is it you can do a motion diagram, or you can plot graphs. I think the graphs is more important than the motion diagram in this case. And once again, I think I've said this several times already, if you can't conceptualize the motion, your chances of success are slim to none. There are some problems that you will not be able to see at first sight. You're going to have to really think about them in detail. So let's go. So the first thing I want to do here is that I want to plot. So I'm going to think about my position graph first. So Maria is running at 9 meters, okay? 9 meters behind Juan. Juan is starting at rest on his motorbike and accelerates. What can you tell me about Maria's running? Probably, note that with Juan, they go out of the way to tell you that he accelerates. The fact that they don't say anything about Maria tells you that Maria is more likely doing what? Running at constant velocity. So what I'm going to do here is that since she's behind Juan by 40 meters, what I'm going to do then is that I'm going to say that Maria, which I'll draw in green, is starting out at the origin. So I'm going to say the position of Maria initially is 0, but she's going to run at constant velocity. So I'm going to pick some slope and I'm going to say, okay, this is her. She's moving at a constant velocity line. Juan is starting ahead of Maria. So let's draw him. So that means if I pick, let's say this spot right here, this is going to be Juan's spot. Man, I'm going to run out of space here. So I'm going to move this over to the left or to the right. So what I'm thinking here is that what's happening is that he's starting at a location 40 meters ahead of Maria. Okay? So he accelerates. So that means if he's starting from rest, we know for a fact that his slope at that point at t equal to 0 better be 0. So now let's go look at what happens here. So then it says, where and how long does it take Maria to catch Juan? What is the time interval during which Maria remains ahead of Juan? So that what that's telling me here is that Maria is going to pass Juan. Since Juan is continuing to accelerate, he's going to pass Maria sometime in the future. So when I'm thinking about this thing here, the first thing that I would be seeing here is that I should have a slope of 0 right here. So what happens? Well, I'm thinking that at some point, I got to look at the speed now. In order for Maria to pass Juan, they have to be at the same location. So then check this out. I'm having a horizontal slope, and then look what's happening right here. Look at this point right here. And what I want you to realize is that Maria passes Juan right here. Why does Maria pass Juan? Because Maria has a steeper slope. She has a steeper slope than Juan, so therefore she is moving faster. And you know what? I want to make this a little bit better. Oh man, I should have practiced this before. So how about if we do this? That looks pretty flat. You know what? I'm going to move this black dot just a little bit higher. Maybe right here. So then I'm seeing this type of thing. And then we're going something like that. So should have drew the curve first. So I'm going to put my black dot right here. So this is the location right there. And then
do we need to know Juan's initial velocity?
He starts from rest. It says it on the question.
Oh, okay. So his initial velocity is 0. Okay.
Yes. And so what happens then, so you could see that we have 2 times. Oops. Right? So I'm going to have an interval, T1, and then there's going to be an interval, T2. And you could see here is that for the interval, so for T greater than T1, Maria is ahead of Juan. For an interval T2, for T greater than T2, we know that Juan is ahead of Maria. So when I go and I look at the question, it says, where and how long does it take Maria to catch Juan? Right? So in other words, this tells us that T1 is the time ahead of, T1 is the time where, when Maria takes to catch, I didn't really say that right. T1 is the time to catch Juan. And then it's asking, what is the time interval where Maria is ahead? And you could see that the time interval, T2 minus T1, this is the time Maria is ahead of Juan. So then, if I look at my velocity curves, just to keep moving in this direction here, so my velocity should be looking like what? I should have a constant velocity, right? For Maria, and so when I'm looking at these things here, I'm actually going to draw this a little bit shorter here, just to make sure that. So when I look at my velocity versus time, what I'm seeing here is that Maria's velocity is going to look something like this here. Her velocity does not change up to here. And you could see that here's my time intervals here. So let me see if I can get this right. All I know is that Juan starts off from rest, but he has to have a steeper slope at T2, right? So when I look at this here, it's looking something like this. Look at this point. So this is a lower velocity. That's why Maria passed Juan. Look at point T2. The slope of Juan is higher than the slope of Maria. That's why Juan is passing her. So now if we agree that this has to be V of Maria, which is 9 meters per second. And then this is going to be the speed of Juan, which varies because he is accelerating. So then if I go and I look at my plot here, what we're seeing here is this for acceleration. We know that Maria is always moving at 0 acceleration. So she's right here, right? Maria's acceleration is 0. Juan has a small positive acceleration. So when I look at his, we're going to assume that maybe it looks something like this here. And so Juan's acceleration is 0.9 meters per second squared. So I have my graphs now, and I think I have a good understanding for the problem because I know that this time right here is one of the times that we got to calculate between 1 and 2, because that's the time that it takes. T1 is the time it takes to catch Juan. So all of these details we have to go in and look for here. So a motion diagram, you know, it's not so great here. So if I was to draw a motion diagram, how would I draw this to actually visualize what's going on? Well, for starters here, we have Maria running, and we know that her speed is 9 meters per second, and we know that her acceleration is 0. But she starts off at the origin. So when I'm looking at this thing, we know that Juan is ahead. So how far is Juan ahead on his bike? Well, we know that the distance from the origin is 40 meters. And what we're really asking here is that because he's starting from rest, but he has an acceleration in that direction as well. And then at some point, what you're going to see here is that she has to be passing him. And so the question, how do you draw this thing? I don't know. Maybe the way we draw this here is that as she's moving at the same location, she's about to pass Juan on his bike when she's moving here and he's moving there. And so in this scenario here, what you're seeing here is that the picture gets quite complicated. And how do you draw this thing here? But at some point, why does Maria pass Juan? Because she has a bigger velocity. Juan's velocity at this point is smaller. But then at some point, Juan's velocity is going to be larger, and Maria's velocity, as she's running, is going to be a smaller one. So which picture do I prefer? Clearly the graph. It has more information. So then I'm going to go start setting up my table here. Okay, we have 2 motions. Okay, we have 2 motions. So if we have 2 motions, what we want to do here is that we want to go in and set up 2 tables, because there are 2 motions. We need two data tables. And remember, data tables are a scheme to organize information. So here we go. So I have my displacement, my acceleration, my velocities, and my time.
What do you mean by there are two motions? Do you mean there's two intervals, or what do you mean by two motions?
Well, there's one for Maria and one for Juan. So for each interval, I have to set up those intervals. So the question is, what you'll see right now. Let's look at, so in this case, I'm going to call this Maria, and I'm going to call this Juan. So the first part of the question was what? How long does it take to catch Juan? So the first part of the question is that
Carlos,
yes.
I have a quick question on the velocity graph.
Okay.
So we were actually discussing this in the chat. I don't know if you've seen, but we're debating whether Juan had to have had a higher velocity in order to pass Maria at t=2.
Yes, look at the slope. That's what I stated. Look at the slope right there. The fact that the slope is steeper, that means that Vj is bigger than that.
But I thought that was the velocity versus time. So I thought the slope indicated the acceleration, not the velocity.
Oh gosh. Okay. At that point, that's the velocity. The slope is here.
Yeah.
Yeah, you could see that Juan's slope is steeper than Maria's slope. So therefore, he is moving faster.
Yeah, but on the velocity versus time graph, they have the exact same velocity at t=2. So how exactly did Juan pass Maria if he had to make up distance?
Okay, let me see if I understand your question here. Oh, damn. My graph is wrong. Thank you for the help. So I don't know if you understood what he says. At this point, he has the same speed, but no. He has to, this is wrong. So look what I'm going to do. I got to erase this. Okay. So what I'm going to do here is I got to take this piece, and the remark is correct. So what happens here is that this velocity has to be faster at t2. And in fact, at some point, the velocity, if you look here, somewhere on this curve, if I look at the slope, let's say right here. It looks to me that the slope here is larger. So therefore, at this point, the speed has to be higher than Maria. So that means if I take that red curve and I take it out, what I'm saying here is that I'm saying that at that point, because the steep is higher, the velocity has to be higher. Well, how do I draw this so at that point, I have to have a higher velocity than Maria at that point. So I'm going to say that it's like right here. And so you're seeing that the steeper slope tells you there. And then according to this picture, maybe at this point, they have to have the same slope right here because that's where the speeds are the same. Is it that way? Not really, not the way I drew it, but that is correct. And again, thank you for helping me out. Hopefully that answers your question now.
Yeah, I did. Thank you.
Okay. I need to be more careful when I do that. Okay, so now moving on here is that the question that we were asking, right? The original question says, where and how long does it take Maria to catch Juan? So what I'm really seeing here is that I'm seeing two things. There's a distance factor that we got to talk about, and then there's a time factor that we got to talk about. So in order to really answer the whole question, I have to calculate the distance x1. That's the distance that Maria needs to do to catch him. And then the time is t1. And then the second time that we were talking about here is that how long does she stay ahead of Juan? So if I go back and I look at my my stuff here, let me see if I can organize this thing here. So what we want to do here is that the question is, maybe I should break this up into pieces here to try to be more clear, is that apparently it has to be this. So what distance occurs when she passes Juan? And what I know about that is that they have to meet each other in order for her to pass him. So in other words, when I look at the distance of Maria, they have to be at the same location. But remember, in this distance here, we know that her acceleration is 0 and his acceleration is this positive 0.9 meters per second squared. So that's how we got to get the distance here. And the other thing here that we have to account for is that we need to know the time required to pass Juan. And according to what we said here, that was that time t1 minus 0, which is then t1. And then the other question that we ask for how long was Maria ahead of Juan? And from our picture, what we said here, we saw that that time interval was really t2 minus t1. So that's the piece of information that I got to get here. So the first question that I'm going to ask then is the distance. Okay, so let's go look at the distance here. So the first thing that we're doing here is that we're going to answer the distance first. So let's do that. So when I'm looking at my table, what do I know? Well, I know that for Maria, she has an acceleration of 0. I know for Juan, he has an acceleration of 0.9 meters per second squared. So what do I know about the initial speeds? Well, I know Maria is always traveling at 9 meters a second because she has 0 acceleration. Juan starts off at rest. And what we're seeing here is that for that interval, what is it that I know and what I don't know? Well, we said that we're trying to find the distance, but if I look at the distance, look what this tells me here. Delta x is not position, it's displacement. And what I know here is that if I look at Maria, she starts off at the origin, and we're going to say that at x1, this is where she passes Juan. And when I look at the displacement for Juan, well, he starts off 40 meters ahead. But if he starts 40 meters ahead, what you're finding here is that his displacement should then be x1 at 40, right? They have different locations here. So what you're seeing here is that this is the distance where Maria passes. So when I go into my table, look how I'm going to write this here. I'm going to write this as what? X1 minus 0. This is going to then be X1 minus 40. And so what you're seeing here is that, note that in both of these intervals here, we can see here that the time where they pass, this of course right here should be what? T1, and this is T1. But note, what we're really trying to solve in each of these cases here is I need this time, I need this time, I need that distance, I need that distance. So what I got to do here, by the way, there's a piece that I forgot to talk about. Note that when I look at the final velocity of Juan at that interval, you know what? I should have put this in red because I want to keep trying to separate these guys. What you're seeing here is that this velocity, I do not know. I do not know how fast it's going when Maria passes him. So here I go. I'm going to look at this equation. So what I'm going to do here, so now I'm going to focus on Maria. And I'm asking the question, distance.
Are those velocities V1 and V2?
Yeah, this would be V2 and V1. Okay, I should have put that in. Thanks for the help. So what you're seeing here is that I know that if I focus on Maria, for distance, she has 0 acceleration. And if I focus on Juan, on his distance, he has an acceleration that's not equal to 0. So in order for them to pass, we wrote this equation already that says in order to pass, the distances must be the same. So I focus on that. So if I focus on this, I know that for 0 acceleration, this must be true for Juan with acceleration equal to 0.9 meters per second squared. So I have 2 different set of equations. So then I'm going to go to the kinematics. So if I go to the kinematics table, let me go grab that. I'm going to put this over here. And then I'm going to just say, what motion gives me 0 acceleration? Well, if I pick the first, so I'm going to focus on Maria right now. So if I focus on Maria, what you're seeing here is that the first equation doesn't have distance. So that immediately tells me that this equation is not even possible. Now, if I look at my kinematics table, I could see that I have everything except time. Okay? I have everything except time. So when I go to look at this thing here, how do I write Maria's equation? Well, I do know that the velocities are going to occur, or the distances are going to occur at the same time. So this guy, I could use this one right here. I could use this one right here, and I could use this, maybe I should use green. So for Maria, I could use that equation, that equation, that equation. Because this one doesn't have time. But if I set the acceleration equal to the second equation, look what happens. If I set acceleration equal to 0, then it tells me that the final speed and the initial speed are the same. So this guy is no new information. I already know that they're moving at the same speed. So I got to use one of these two for Maria. So I'm going to choose to use this guy right here. So if I choose this one for Maria, this tells me here that this equation for Maria then reads V Maria initial times T1 plus 0. Now I got to go focus on Juan. Juan has acceleration. So when I look at this thing here, what I'm going to do here is that the only way I can describe Juan's distance that has time in it has to be the third equation again. So if I look at Juan, it says, I'm going to have what? I have a problem that I did not account for. And let me show you what I mean by this. When I look at the distance of Maria, it has what? It's really x1 minus 0, which is equal to x1. And in this case, it's Vm initial of Maria at that 1 times T1. Now look at Juan. When I look at Juan, his distance is x1 minus 40. So I have to include that x1 40. But note, in order for me to solve for the distance, I have to equate this x1 to that x1. So when I look at Juan, I got to be really, really careful. So for Juan's equation, what I really got to do here, I have to bring that 40 to the other side. So when I look at this, I know that the motion of Juan is going to involve the initial velocity of Juan times T1 plus his acceleration at that time, T1 squared. So note how I have this 40 that I have to move to the other side, because we must equate x1 values. So if I do that, I have equation 1 and I have equation 2. Equation 1 reads what? That x1 equals the initial speed of Maria times T1. Now, if I look at equation 2, you could see here that if I bring over the 40, I get x1 is equal to what? 40. But the initial speed of Juan is 0. So then this gives me 1/2 a Juan T1 squared. So now I can equate both of these variables together. So if I do that, then I get the initial speed of Maria times T1 equals 40 plus 1/2 a of Juan T1 squared. So what you're seeing here is that this guy gives me a quadratic equation. Okay, so what we just derived is that we must solve this quadratic to get T1. So let's go look at that. Let's go solve for it. So what I'm going to do then is that I'm going to put in my numbers that look something like this here. So I'm going to adjust this thing. So I'm going to bring over the velocity term and put in my numbers. So I'm going to get what? I'm going to get 1/2. Here's his acceleration, T1 squared. I bring in Maria's speed, which is 9. I get T1, and then I get plus 40 equals to 0. So note, I'm going to get two solutions, right? Quadratic equations give two solutions. But what are those two solutions going to be here? The solutions, because of the way we set it up here, is that these are when Maria and Juan are at the same locations. So if we go back to our graph, look what the graph looks like. if I come all the way over there, look at this point T1 and T2. That's the points that they are. So what we're actually solving for in the quadratic equation is the time that Maria is ahead and then the time when Juan passes Maria. So if I go back and look at that, those are exactly the times that we're looking at. So in this case, we get both T1 and T2 simultaneously by solving these guys. So let's go do that. So if I do this, I'm going to focus on this thing and I'm going to say, I now have a solution. So if you solve this quadratic, you get this. You get T1 equals to what? 6.67 seconds. And T2 equals to 13.3 seconds. I now have the solutions for the time. So now that I have that, I can answer the question, how long is Juan in front of Maria? Okay, so then the question I'll answer here is that how long was Juan initially ahead? Well, the answer to this here, it has to be T1. This time is 6.67 seconds. So we know that for a fact. And then we ask the question, how long is Maria ahead of Juan? So if I come over here and then I say, how long is Maria ahead of Juan? And in this case here, it's the difference between T2 and T1. So in this case, it's 13.3 minus 6.67. And if you reduce this, you get 6.67 seconds. So that's how long we know. So then we ask the last question is, how long or how far, right? How far is Juan when Maria passes? So we're really asking a distance here. We know that Maria is moving with acceleration equals to 0. So there's only one possible equation that you could use, right? There's only one possible equation. And that equation has to be the distance, the velocity of Maria times her time. So this is the so-called passing distance. So I know her speed, which is 9 meters per second, and I know how long, which is 6.67 seconds. So if we
Carlos.
do that, yes.
Actually, a lot of us in the group chat got 6.63. I don't know if it really matters, but
I guess the number of sig figs, I wonder if there's,
I think it
I
depends when you
didn't
round
reduce,
it.
yeah, it depends. I didn't round until the very end. Yeah, but you know what? I think that's a tiny issue, right? If it's 6.63 versus 6.67, it's still the process. So I don't know the number of sig figs right now because I don't have my calculator when I did it. I wondered if I just rounded at the end, but I don't know the answer to that. So I'm going to assume for right now that it's just 6.67. And if it's a little, it might be a little bit off. So if you compute this, I end up getting 60 meters. And I think in the end, I'm typically reducing this to 2 sig figs because I think the problem only has 2 sig figs. And so I think I should have written this as 6.7 seconds and this as 6.7 seconds. I don't round until the very end when I'm trying to put the number down. So I'm going to say that this is the passing distance initially.